Welcome to Unit 1, Lesson 3, different types of sequences. Okay, let's look at other types of sequences. Okay, consider the function given by f of n equals 3n minus 7. So, when we see this notation right here, this is called function notation, that we say at f of n. So, f is the output. So basically, you use the y. Let me get off of highlighter. Sorry about that. You're used to y equals 3n minus 7. Now, we're in algebra 2. We're going to change y, the output, to f of n. It's the same thing, but the variable is your input. So that lets you know whatever the variable is your input. So now evaluate this. So to do f of 10, you put 3 times 10 minus 7. So this goes in for n, and get 30 minus 7, which equals 23. So then get f of 10, which is 23, then minus 1. 23 minus 1 equals 22. All right, for the next one, f of 10 minus 1 is f of 9. It's inside the parentheses, so PEMDAS. Do what's inside the parentheses first. So 3 times 9 is 27, equals 3 times 9 minus 7, which equals 27 minus 7, which is 20. Then the next one, we get f of 5 minus f of 4. So you get 3 times 5 minus 7 minus 3 times 4 minus 7. 15 minus 7 is 8. 12 minus 7 is 5, which gives you 3. Okay, here are the values of the first 5 terms of 3 sequences. So now, figure out what's the change in term A. In sequence A, a sequence is just a list of numbers. That's all a sequence is. You go 30, 40, 50, 60, 70. So we can see we're adding 10. In sequence B, this is a little trickier. Let's see, 5. To get from 0 to 5, you add 5. Then to get from 5 to 15, you add 10. Then to get from 15 to 30, you add 15. All right, so then plus 20. All right, so this is changing, it's increasing by 5 every time. All right, so this is a weird change. For sequence C, 1 times 2 is 2, 2 times 2. All right, so this is times 2. And we know this is geometric. So I'm going to write a G there. And which sequence had the second greatest value for the 10th term? So we got to come back up. 1, 2, 3, 5. So we got to go 80, 6, 97, 100, 8, 110, 120. And then for the next one, we're going to go plus 25 is 75, plus 30 is 105. Plus 25 plus 30 plus 35 plus 40 plus 45. 1, 2, 3, 4. That's 5 terms. All right, for the next one. 16 times 2 is 32. Times 2 is 64. Times 2 is 128. Times 2 is 256. Times 2 is 512. Okay. Which one has the second greatest value? The green one has the greatest. The blue one has the second greatest. So let's highlight that. That's the second greatest. Which of these could be geometric? Explain how you know. Well, C, we already determined C was multiplying. It's geometric because it's multiplying. And that's how we know. Okay. Jada and May are trying to decide what type of sequence this could be. Jada says, I think this sequence is geometric because the value in the volume column in each row is 3 times the previous row. May says, I don't think it is geometric. I graphed it and doesn't. All right, so let's see what we got here. So 2 times 3 is 6. 6 times 3 is 18. Sequences deal with the output. So on a vertical table, on the left is your X values, and on the right are your Y values. So everything is looking good, but I see a problem somewhere. Can anybody spot the problem? The problem is in your X values. You go from 1 to 2, then you jump to 5. There are some jumps missing here. So if I redraw the table, 1, 2, 3, 4, 5, and I go 2, 6, 18, now I got to try some things out because times 3 doesn't work because I got 2 numbers missing in between. So if it's not times, how else can we get from 2 to 6? Well, we can add 4. So 6 plus 4 is 10. 10 plus 4 is 14. And 14 plus 4 is 18. Now, how did I know to do this? On your inputs, your X values, they must increase by a set amount. You can't go from 1 to 2 to 5. You must go 1, 2, 3, 4, 5. Or some other set amount, but each interval must be the same. So think about that and remember to look carefully at the data that you're given. It must, on the X values, it must go up by the same interval each time, which is plus 1. Okay, how are arithmetic and geometric sequences alike and different? Okay, so the new word for today is an arithmetic sequence. When you see the word arithmetic, think plus, minus. When you think geometric, we always think multiply and divide. So an arithmetic sequence, like for anything that adds or subtracts is arithmetic. So how are they alike? They both grow. So let's do the alike on the left. So alike, different. They either grow or shrink. They either increase or decrease. They had the same number acting between each term. Same number operating. We're going to use a math word, operating. In math, there are only 4 operations. Add, subtract, multiply, divide. Same number, I wrote operation because I was talking and writing. Same number operating on each term. How are they different? Well, obviously arithmetic sequences add and subtract. So arithmetic sequences give you linear graphs. And we'll look at that when we get to the practice problems. Geometric sequences multiply and divide, and they give you curve graphs, and they grow much faster than linear sequences because you're dealing. All right. So we didn't talk about this one much in class specifically. All right. Can you explain what it means for a sequence to be arithmetic or geometric? All right. So again, arithmetic, plus and minus the same number between each term. Geometric, multiply or divide the same number between each term. That's the key. Okay, an arithmetic sequence, whenever you see arithmetic sequence, plus or minus. So let's say 2 plus 2, 4, 6, 8, 10, 12. That's a list of numbers. If I got 30, if I minus 3, I get 27, I get 24, I get 21, I get 18. So this sequence is plus 2, this sequence is minus 3. It must be the same number acting on each term. Geometric sequence is multiply, divide. So 1, 2, 4, 8, 16. So each one is multiplying by 2. Now, 256, because we saw this in the Sierpinski triangle, 64, 16, 4, 1. This is divide by 4 or multiply by 1/4. Geometric sequence is the same number operating on each term.